In this video, we're going to be doing a Unit 2 Forces MCQ practice. So for this first question, we had a 5.0 kilogram block being pushed along a horizontal surface with a force of 20 newtons at an angle of 30 degrees above the horizontal. The coefficient of friction is 0.2. What is the acceleration of the block? So the first thing you would have done here is you break this force that is at an angle into components. So you have your vertical force component and you have your horizontal. And then you have your definition of your system forces. To the right is going to be a horizontal x force, and then upwards is going to be a positive y vertical force. So then you take the summation of your forces in both the horizontal and the vertical direction. So normal force is going to be acting upwards on the block, which is this. So that's Fn. And then downward, you have the weight, which is equal to mg, which is also equal to Fg. So those are going to be in opposite directions. That's up and down. So Fy is going to be acting in the vertical direction because it's upwards. So then you have to add that as well. So that if you saw that, what you can rearrange that and you can substitute in your value for mg to solve for Fy. So here Fy is equal to 20 sine theta using trigonometry, so you get 10 newtons. So you substitute 10 in there, and then you get your normal force is 39 newtons. Here for your Fx, you take your summation of your forces in your horizontal direction. So you have Fx, which is this horizontal component here, and using trigonometry, that's 20 cosine of 30 degrees. So you take 20, which is going to be the force, and then you do cosine of the angle, and the angle is 30 degrees. So that's 17.32 newtons. So here you had Fk, you have to find Fk as well. So Fk is equal to mu k, which is your coefficient of friction times your normal force. So we just found our normal force was 39 newtons, and we know that the coefficient of friction is 0.2. So that's going to be 0.2 times 39, and that's 7.8 newtons. So if you substitute everything back in, you have 7.32 minus 7.8 is equal to 5 times a, your acceleration. So that's going to be 9.52 is equal to 5.0 times a. If you divide both sides by 5.0, a is equal to 1.9 meters per second squared. So that is your acceleration of the block. So a 2.0 kilogram object is in equilibrium under the action of 3 forces. Two forces, let's actually just write that. It's 2.0 kilograms. So two forces are 10 newtons to the east, 10 newtons east, and one is 6 newtons north. So what is the magnitude of the third force? So for this question, what is the condition to have a state of equilibrium? That means that the summation of your forces is equal to 0. And what does that mean for our third force? That means that the third force must cancel the resultant of the first two. So we have to find the resultant of the given forces. So your resultant force is equal to the root of 10 squared plus 6 squared, and that's equal to the root of 100 plus 36, which is equal to the root of 136, and that's approximately 11.7 newtons. So how do we interpret 11.7 newtons? We know that the third force has the same magnitude as the resultant force, but opposite direction. So that's our magnitude, 11.7 newtons. A 3.0 kilogram object is attached to a vertical spring and is in equilibrium. The spring's constant is 150 newtons per meter. What is the extension of the spring? So when you have your spring force is going to equal to your gravity, your force of gravity. So if you rearrange this, you can solve for just x. X is equal to the mass times gravity divided by your spring constant K. So that's equal to 3 times 10 divided by 150. So the answer is B. A box of mass 4 kilograms is pushed up a 30-degree incline with a force parallel to the incline. Your coefficient of friction is going to be 0.25. What force is required to move the block at a constant speed? So what force is pushing it up at a V is equal to constant? So we don't know what the force is. When you have constant speed, this means that your net force is equal to 0. Therefore, your FA is going to balance your FG components, which includes Fx and Fy, and also friction. So our gravity is acting from the center of mass, and force of gravity is equal to mass times gravity. But our axis, we're going to make this adjusted to be this. So this is going to be our axis. So that means that your FG can be broken up into a vertical component and also a horizontal component. So you have upwards from the ground, you have your normal force like that. And you also have friction that is in the opposite direction of your motion. Say here, UK is equal to 0.25. That is your force of friction. So let's tackle our components of gravity. Mg is equal to 40 newtons. Mg sine of theta is going to be 30 degrees, is equal to 40 times 0.5, which is equal to 20 newtons. Your normal force is equal to Mg cosine of 30 degrees, which is going to be 40 times 0.866. Now for friction, Fk is equal to Mk times your normal force, which is going to be 0.25 times 34.64, which is approximately 8.66 newtons. Now your force have to balance out. So that means your Fa is equal to your Mg sine of theta plus your Fk, which is equal to your 20 plus your 8.66, which is equal to 28.66 newtons, which is approximately going to be 29 newtons. A 10 kilogram mass is suspended by 2 ropes making angles of 30 degrees and 60 degrees with the horizontal. What is the tension of the rope at 30 degrees? So for this question, let's say we have, this is going to be a horizontal like this. And you have 30 degrees and 60 degrees. Actually, that's not the angle. So if it's 30 and 60, you know that this is actually going to be 90 because it's a 30, 60, 90 triangle. So we want the tension at the rope at 30 degrees. Weight is equal to mass times gravity. Your weight is going to be 10 grams, 10 kilograms. So that's 10 times. This is approximately going to be equal to 100 newtons. So you have horizontal equilibrium. So this is going to be divided by cosine of 60 degrees, cosine of 60 degrees. So T2 is equal to 1.732 T1. Now you also have vertical equilibrium. This is T1 side 30 degrees plus T2 side 60 degrees is equal to mg. So T1 times 0.5 plus 1.732 T1 times 0.866 is equal to 100. So your answer is 50 newtons for T1. Now for our next question, an elevator accelerates upward at 2 meters per second squared. So you have constant acceleration. And let's say that the summation of forces is equal to MA. So your person is standing on a scale inside of the elevator. So actually redraw this elevator so that you can see the scale. But the person is standing here and they have a normal force that's acting on them. But the person also has a weight force that is acting down. And our direction of acceleration is up. And we're going to find this system like this. So we have normal force that's acting up, and you have your weight of your person, which is equal to mg, acting down, is equal to ma. So here, you could just add mg to both sides. So this is equal to ma plus mg. But then here, you see you have two m's, so you could factor that m out. That's equal to a plus g. So now all you have to do is just plug in your values. So that's your normal force is equal to C, 840 newtons. A 2 kilogram block is on top of a 5 kilogram block. The bottom block is pulled with 21 newtons on a frictionless surface. What's the acceleration of the system? (21 newtons on the frictionless surface. It doesn't say it's at an angle, so we're just going to assume that it's like this. We want the acceleration. So what you have to do here is you treat these two blocks as one system. That's because you have no slipping mentioned. So they move together. So let's find our total mass. That's equal to 2 plus 5, which is 7 kilograms. Now you just use Newton's second law. And you solve for A. So that's equal to 21 over 7, which is 3.0 meters per second squared, which is B. A car of mass 1,200 kilograms rounds a flat curve of radius 50 meters at 20 meters per second. What provides the centripetal force? So you're on the road and you're going on a curve like that. So let's say you're like this person right here. That's the center. Okay, this is like let's do the center be like right here. So what is providing the centripetal force when the person is like going like this? It's like keeping them pushing in a circle. So the answer is on your road, on your flat road, your person has a normal force that is upward, and they have a force of gravity that is downwards. So there's a summation of your forces in the vertical direction that's going to equal to 0, because you're not moving up and down. You're only moving left and right. So that means that the imbalance has to happen because your summation of your horizontal forces does not equal to 0. So that means that your friction is going to cause your inward centripetal motion. Causes your FC inward. A 0.5 kilogram object is in circular motion at 4 meters per second in a circle of radius 2.0 meters. What is the centripetal force? So centripetal force is equal to mass times velocity squared divided by radius. So this is going to equal to 0.50 times 4.0 squared divided by 2.0, which is your radius. And this is going to simplify to just 4 newtons. Your answer is B. A block rests on a horizontal surface. The coefficient of static friction is 0.4. What is the maximum horizontal force that can be applied to a 10 kilogram block before it begins to move? So if it's at rest and we're looking at before it's going to move, this means we're not looking at kinetic friction, because kinetic friction means you have a friction force that is acting, that is reducing your motion, but that means that you're also already moving. But if it's not moving yet, that means you have a state of static friction because the molecules are being held in place by a current situation. So it's a static object. It's not moving yet. That is equal to mu(s) times n. And if you had Fk, for example, that is equal to mu(k) times normal force. But you just replace the Fs and the mu with the type of friction that it is. So we know that normal force is equal to mg. So we know mg here is going to be 10, and we're going to use 10 to approximate. So 10 to approximate gravity, which is 9.8. So we'll say that that's approximately just 100 newtons. And you can also plug in your coefficient of friction, which is 0.40. So you get 40 newtons as your Fs max that is keeping the object in place before it begins to move.